Hello. Today we're going to talk about Topic 4, Section 16, confidence intervals. Okay, so usually you don't have access to the whole population, right? So you do have maybe one sample or, a few samples, but you want to predict the population. How sure are you that that sample is the same as the population? That's where confidence intervals come into play, okay? This is where you can say things like, I am 95% confident that the population mean is within this interval based on my sample, all right? Let's do an example. So you collect the heights of 10 people, you find your mean, and you know that the standard deviation for the heights of the population is this. Don't ask, you just have it, okay? Calculate a 95% confidence interval based on that. So you're given the standard deviation. So that's super nice because you just go to your calculator. Oh, let me put it in the window. Okay, so you go to Stat, Tests, and you're going to go down to number 7, Z interval. That's what you want to use given the standard deviation. So we have statistics, so we're making sure we're using this. We don't have raw data. Then we have the standard deviation. What did they say? It was 7.6. All right, 7.6. The mean is 172, and we had 10 people. We want a 95% confidence interval, so you put it as 0.95, right? You don't put it as percentage, you put it as a decimal, and then you calculate. There's your interval. I don't know why I say that weird. All right, so you go to your Z interval, you put in your information, okay, and then you hit calculate. So this is what your calculator spits out, 167 to 176. So therefore you are 95% confident that the mean of the population is within those numbers. Okay? All right, example number 3. So you read this, okay, mass of plums. All right, and here you have your variance. So your standard deviation would be 4. You put all that into your calculator, so put that into your list, and then when you go to your tests and you do number 7, Z interval, you now use your data. So your list 1 would contain all of this. So then our our variance was 16, so it wanted the standard deviation, so that would be 4. And here we want an 85% confidence interval, so we calculate that, and let's see, that is exactly what we get. Okay, so the confidence interval is between those numbers. All right, so, but we wanted to find the length of that interval. So we take the difference, the upper value minus the lower bound, and we get 2.97. So that's the length of that interval. So we are 85% confident that we have found the population mean within less than 3 grams, right? Within that range of 3. Okay. All right. Keep it rolling. Here's our confidence interval not given the standard deviation. Oh, that's what T intervals are for. So T is when I don't know. Okay. All right. And Z represents the knowing the population. So knowing that standard deviation. Okay. So now we do example 1. Plug this in. And again, your standard, I don't know why I said again, your confidence interval for T is right below Z. So 7 and 8 are your intervals that you want to calculate. So you plug this in, you're doing statistics, you put your information in, and that's the interval you should get. So you're 95% confident that the population mean is between this and this. Okay? So it's a good chance that your sample is one of the good samples, right? Because our mean of that sample was 17, and it was within that range. Okay. All right, example 2, then we're given raw data, which is great because it's the same as the other data, right? Okay, so now we don't know the standard deviation, all right, but we want an 85% confidence interval, so use T interval on your calculator again, but now you use data. So make sure you put that into your list, which it should be from the last one. All right. That's everything you need to know. So you should know for 4.16. If you have any questions, you know where to find me.